Annenberg Lerner.
1, 2, 3, 4.
Hi, my name is Annalie Lethko, and this is For All Evens. Today we will be covering discrete probability distributions. The outcome of a probability experiment is a count or a measure called random variable. Random variables can be discrete or continuous. A random variable is discrete if it has a countable number of possible outcomes. It is continuous if it has an uncountable number of possible outcomes.
For the discrete number line, x can have only whole number values such as 1, 2, or 3. For the continuous number line, x can have any value between 0 and 24.
A discrete probability distribution lists each possible value with its probability.
A discrete probability distribution must satisfy the following conditions. 1. The probability of each value of the discrete random variable is between 0 and 1 inclusive. And 2. The sum of all the probabilities is 1.
You can measure the center of a probability distribution with the mean, the variability with the standard deviation.
The mean of a random variable represents the theoretical average of a probability experiment and sometimes is not a possible outcome. And although the mean of a random variable of a probability distribution describes a typical outcome, it doesn't say how the outcomes vary. To study a variation of the outcomes, you can use the variance and standard deviation of the random variable of a probability distribution. The mean of a random variable represents what you would expect to happen over thousands of trials. It's called the expected value. The expected value of a discrete random variable is equal to the mean of the random variable.
There are many probability experiments for which the results of each trial have two outcomes, success or failure. For example, when a soccer player attempts a penalty kick, they either make it or they don't. This is called a binomial experiment. To be a binomial experiment, it has to satisfy four conditions. 1. There's a fixed number of trials, and each trial is independent of the others. 2. There are two possible outcomes, success or failure. 3. The probability of success is the same for each trial. And 4. The random variable x counts the number of successful trials. By listing the values of x with their corresponding probabilities, you can make a binomial probability distribution. Thank you for watching. I'm Annalie Lethko, and this has been For All Evens. We'll see you next time.